Hello again. This is the second video of data warehouse and OLAP. I would like to explain about data warehouse design and usage and implementation, and I will summarize the content of this slide. When we want to design the data warehouse, there are some design process. The first design process, we call it top-down. The top-down, it starts with overall design and planning. So you need to make a mature design, okay, and you can make the data warehouse. But some of the design approach, we call it bottom up. The bottom up approach means start with experiments and prototypes. So from the small, okay, start from small and then make a bigger one and make bigger one and bigger one. Okay. It is rapid. Okay. But it can be a combination of both. It can be combination of top-down. It can be a bottom-up approach. From software engineering point of view, we can have the data warehouse design as a waterfall. Waterfall means structure and systematic analysis at each step before proceeding to the next. So we finish the requirement. And then after we finish the requirement, we go to the design. After we finish the design, we go to the implementation. After we finish the implementation, we go to the verification. After we verify, we do the maintenance. Or we can do the spiral. The spiral means rapid generation of increasingly functional system. So it is short around time. For example, we have the first step, second step, third step, and fourth step. So first, determine the objective. After we have the concept requirement, we develop with the simple one and then plan the next iteration. Okay, we make with the simple prototype one. After we have the prototype one, again, we test and then we go to the next iteration, again, determine the objective and we develop the prototype two. And so on. So we develop the operational prototype and we can release it. So this is the spiral process. In the data warehouse design process, we need to understand the typical data warehouse design process. We need to choose the business process tomorrow. For example, we want to choose orders. Okay, the orders is the data that we already learned in the previous section about the transaction or the invoice. If this process is organizational, then a data warehouse model follows. If the process is departmental, a data mart model follows. Okay, so you know, organization. So it means one big company. So you can use the data warehouse. If it is department, for example, I want to have the marketing department or sales department. Okay, then in this case, you can think about data mart. You need to choose the green. What is green? It is the atomic level of data. So the atomic level means how small the data that you want to look at in the data warehouse. For example, you want to know about the product name only. Okay. If it is only the product name, then yeah, you need only the product name without any details. But if you want to make more details, product name, maybe the product spec, you want to have the product origin and etc. Then it means you will make the whole business process. So you want to get the supplier, you want to know about the delivery and etc. Okay. To choose the dimension that will apply to each fact table record. So for example, you want to get the item, you want to get the time, you want to know the supplier. Okay, so this is the dimension, and choose the measure that will populate each fact table record. Okay, the measures, we have the distributive, algebraic, and holistic. So yeah, we have the distributive, algebraic, and holistic measures. So you need to figure out what are the measures for that data warehouse. So this is the recommended approach. When you need to define the high-level corporate model. So if it is a high-level corporate model, then okay, you need to think about the enterprise data warehouse. Or you can think about the specific department, let's say the data mart, and then you have another data mart, and after you have multiple data mart, you can build a distributed data marts. Okay, after you have the distributed data marts, okay, you can make the multi-tier data warehouse. But actually, this step is also available, and this step is also available. Okay, so yeah, this is just a recommended approach how you can design the data warehouse. So the data warehouse uses three kinds of data warehouse application. First is about the information processing. The information processing means you can support query. You can provide the basic statistical analysis. You can do reporting by using cross-tab tables, charts, and graphs. The analytical processing means you want to show the multi-dimensional analysis of the data warehouse data. And yeah, you know already the basic OLAP operations. For example, drill down, roll up, slice dice, okay, drilling, pivoting. And yeah, this is the most important part because this is a part of our course. This is data mining. So in the data warehouse, we can do the knowledge discovery from hidden patterns. It supports association, constructing analytical models, performing classification and prediction, and presenting mining results using visualization tools. So from online analytical processing or LAP to online analytical mining. Why online analytical mining? Because high quality of data in the data warehouse. We already create the data warehouse. It is to have the integrated data. It is to have a consistent data. It is to have the clean data. And the OLAP, based exploratory data analysis, it is to drill, dice, and pivoting. Meanwhile, for the selection data mining functions, yeah, we need to deal with the OLAM. It is to integrate and swapping of multiple mining functions, algorithm, and tests. Maybe in one mart, for example, the marketing data mart, okay, yeah, we can apply the classification. Okay, and we can apply the classification with the algorithm A. We can apply with the algorithm B, and we can apply with the algorithm C. And then in the marketing data, in the data mart, we can also do the clustering. We can do the clustering with the algorithm D, with algorithm E. Okay, so with this kind of thing, yeah, the online selection of data mining function can be switching or swapping easily. So the efficient data cube computation. The data cube can be viewed as a lattice of cuboids. So you already learned about the cuboids. Yeah. So if we have the all data, we can separate into one dimension. We can separate it again into two dimension, and the latest one will be the 3 dimension. The bottommost cuboid is the base cuboid, and the topmost cuboid or the apex contain only one cell. So this is containing only one cell. Now we need to measure how many cuboids in an n-dimensional cube with L levels. Okay. What does it mean by L levels? Well, you know, in the time, okay, time or date, we can have several levels. Let's say if we have 3 levels, then the time can be about day, and then maybe it is month, and maybe it is year. So it is 3 level. So this is the lowest level, the middle level, and the highest level. Okay. That's the meaning by level. And what about the n-dimensional cube? The n is this one. We have 3 dimensions, okay, so or 3 attributes. So the formula is like this one. This refers to product or multiplication. Okay. If I have n equals to 3, and each dimension has 1 level. Okay, then date is only 1 level. Maybe the product is only 1 level, and the country is only 1 level. Then the t, okay, it means the number of cuboids will be 1. What is 1? This is Li. Li refers to the level, okay. Li plus 1. Okay, Li plus 1. That, so we can have Li is 1 level, and then we have only 1 and power of 3. Power of 3 means we want to multiply for 3 times. This is I equals to 1 until n. So it means 1 plus 1 plus 1 plus 1 plus 1 plus 1. Oh, sorry, not plus. This is multiply. Okay, multiply. So if it is multiply for 3 times, it is the same with the 1 plus 1 power of 3. Then it is 8. You can look at this one. We have 1, 2, 3, 4, 5, 6, 7, 8. Okay, with 3 dimension and 1 level, so we have 8 cuboids. Okay, we have 8 cuboids. What about if we have n equals to 10 and each dimension has 4 levels? Then we have 4 plus 1. Because we have 10, so we power with n. A data cube of 3 dimensions, like time, location, and item. The total number of cuboids is 2 multiplied by 2 multiplied by 2. So the cuboid contains time or none. Suppose now time has 3 levels of hierarchy. So month, quarter, and year. Then for the time, we have 1, 2, 3. We have 3 levels. Okay. There are 3 levels of the hierarchy. So based on the formula, this 3 plus 1. And what about the other? The location is only 1 level. So 1 plus 1. And the item is only 1 level. 1 plus 1. Then we can have 4 multiplied by 2 multiplied by 2. Then the total of cuboids will be 16. Okay. So we can separate like this one, or yeah, we can combine with just a single formula like this. So for efficient data cube computation, okay, we call materialization of data cube. We can do the materialize every cuboid or full materialization, or none, this is no materialization, or some partial materialization. We need to select of which cuboids to materialize, whether we want to select based on the size, based on the sharing, or access frequency, and etc. So for example, in the compute cube operators, we have the MQL, data manipulation query language. So we can define the cube cells, whether it is the item, city, year, okay, and what we would like to know is the summation of the cells in dollars. So compute the cube cells, and yeah, we can transform it into an SQL-like language. For example, I want to know the item, city, year, and then do the summation of amount from sales. So sales is the data warehouse, okay, and cube by item, city, and year. If we want to select only groups, okay, so for example, I want to select all, then date, product, customers. So if I want to select only the groups, date, and product, yeah, we can also do that one. Or I want to select based on the date and customer, or I want to select based on the product and customer, or I want to select only date, or I want to select only product, or I want to select only customer. So this is based on the cuboid that we already measured before. So if we deal with all those things, we call this is the full materialization. So we want to materialize every cuboid, but sometimes we want to have only partial materialization. So we call it the partial materialization or sum of the cuboid. When we do the efficient processing or LAP, we can determine which materialized cuboids should be selected for the OLAP. For example, let the query to be processed be on brand and province or state with the condition year equals to 2020. So there are 4 materialized cuboids available. First, I have the year, item name, and city. Second, I have the year, brand, and country. Third, I have the year, brand, province, or state. Fourth, I have the item name, province, or state, where year equals to 2020. So which should be selected to process the query? Okay, so this is the question. I have this query, brand and province or state, and the condition is year equals to 2020. So which query is the best representation? Query number 1 or query number 2 or query number 3 or query number 4? Okay. Yeah, this is a little bit tricky. Okay. We can select 3 or 4. If we select the 3, then we will use a condition year. Okay. We can do the condition later on. If we use the 4, the item name, we need to look at the item name. Where is the location of this item name? So note this one. there is the hierarchy on the dimension. The city is the smallest hierarchy, and then we have the province or state, and then country. We have month, and then quarter and year. We have item name, and then brand, and then type. So it means if we choose this one, okay, if we choose this one, we need to roll up to brand because item name is the smallest item, and then the province or state, yeah, it represents of this one, and the year is exactly the same with the condition. If we choose this one, the year we will make a condition on the 2020. It is not difficult, and the brand is already precise, and the province or state is already precise. Okay. But what about this one? The year we need to define the condition, the brand, okay, because it is the brand, and the country. So we need to go down, drill down into the province or state. What about this one? Year, okay, we can make the condition 2020 later, the item name. So the item name, yeah, it means we need to roll up to brand, and then we have the city. So the city we need to roll up to the province or state. So if you use this one, there will be 2 times of operation. Okay. If you use this query, you need 2 additional more operations for getting this query. If you use this one, you have 2 more operations because the country should be drilled down and you need to make the condition. Okay. And if you use this query, you need to also make 2 conditions, which is year and province or state already, brand is also already. So it means you have only 1 condition, 1 more condition for the OLAP. If you do with this one, the item name should be roll up to brand, province or states. Okay, you already did this one. You already have this as the query, and the condition is already mentioned. So it means you have only 1. Then it means the option can be 3 or 4. If it is more efficient, maybe we can look at the number 3, because usually adding this kind of condition will be easier than doing this one. Yeah, choosing this one with 1 condition, year equals 2020, it will be more efficient rather than roll up the item name into the brand. Okay, so the efficient processing of OLAP will be this one. So the OLAP architecture will be different if you are dealing with the DBMS. DBMS, it is the database management system. We can have the relational OLAP or rollup. It uses relational or extended relational DBMS to store and manage warehouse data and OLAP middleware. It includes optimization of DBMS backend, implementation of aggregation navigation logic, and additional tools and services. It shows a greater scalability. But there's another kind of OLAP, which we call it multidimensional OLAP. It is a sparse array-based multidimensional storage engine, and then it fast indexing to pre-computed summarized data. There's another kind of OLAP, we call it hybrid OLAP, like the Microsoft SQL. It shows the flexibility, low level, and the relational, and in the high level, we use array. So they split the way If it is low level, yeah, just use the relational, like the relational OLAP. If it is a high level, they use array to make it more optimum. Okay, so how many data warehouse design process that you learn? Okay, we have top down and bottom up. And from the software engineering point of view, we have waterfall and spiral. Mention 3 kind of possible application from data warehouse. 3 kind of possible application. Yeah, this one is the application. It can be for the information processing, analytical processing, and data mining. How many cuboids in a 4-dimensional cube with 2 levels? Okay, so we have 2 levels plus 1. Okay, because we have 4 dimension, then you can just directly power of 4. So it is 3 power of 4. Then we have like 81 cuboids. Okay. What are the OLAP server architectures? Okay, you have the relational OLAP, multi-dimensional OLAP, and hybrid OLAP. Okay, so we learn about the data warehouse, and you learn about the data cube, about the dimension and measures. We learn about the star schema, snowflake schema, fact constellation, and some basic OLAP operation like drilling, rolling, slicing, dicing, and pivoting. So we learn also the data warehouse architecture and design and usage. We learn about the multi-tier architecture. We learn that the usage of the data warehouse can be for information processing, analytical processing, data mining, and also OLAM, online analytical mining. And the implementation for the efficient computation of data cubes, we can either partial materialization or full materialization or no materialization. And we can also do the OLAP query processing. And the OLAP servers can be about ROLAP, relational OLAP, or multi-dimensional OLAP, or hybrid OLAP. Okay, that's all about the data warehouse. Thank you very much for listening, and we will meet on the class or in another video. Thank you. Have a good day.